Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Here we can see the increment time for the counter is 1 second. But if someone will press the switch 1 continuously, now we can observe that our program is stopped and there is no increment in the counter value. Let's find the reason why it is happening. We can observe from our program that we are reading a switch which is connected on port D4 and the debouncing interval time is 50 milliseconds. And if we will press the switch 1 continuously, so each time 50 milliseconds will be added to the time of increment of delay register. Presently the increment time for delay register is 84 microseconds, but if we will press the switch 1 continuously, so 50 milliseconds will be added in this time. And now if we will multiply 50 milliseconds by the number, that is 11,905, so we will get the time of increment of delay register by 1. 50 milliseconds multiplied by 11,905 equals to 595.25 seconds. So if switch will be pressed, so each increment in delay register will take the time, that is 595.25 seconds. Now here we will use an interlocking technique to overcome this situation, and we will use a flag, that is switch 1 interlock flag. So here we will assign another bit variable, that is bit switch 1 intlk underscore flg is the name of the flag that we will use as interlock bit in our switch routine. So first we will initialize this flag, that is switch 1 interlock flag in initialization routine. So I will copy this flag from here, Ctrl C, and I will paste it here, Ctrl V, equals to 0. Now here in switch routine, if switch 1 that is connected on port D4 is pressed, so our program will come into this if statement and it will set SS flag, and here we will set the flag, that is switch 1 interlock flag, Ctrl V, equals to 1. Here we have set the flag, that is switch 1 interlock flag if the switch 1 that is connected on port D4 will be pressed. Now here in this routine we will use another if condition. If switch interlock flag, Ctrl C, Ctrl V, equals 0, and here we will close our first if condition. Here we can check. It means that if switch 1 interlock flag will be 0, then our program will come into this if statement and it will set SS flag, that is start stop flag, and it will also set switch 1 interlock flag. And if the value of switch interlock flag will be 1, so it will not come into this if statement and will not read the status of switch connected on port D4. Here we can write remarks, that is switch 1 interlock flag. We have set the interlock flag in case the switch 1 is pressed. Now we will reset the interlock flag if switch 2 will be pressed. So we will copy this statement from here, Ctrl C, and we will paste it here, Ctrl V. If switch 2 which is connected on port D5 will be pressed, so we will clear the status of this flag and we will reset switch 1 interlock flag. Now we will compile our program and we will check the results once again. Okay, compile. Our program is compiled successfully and there is no error in our program. Now we will download the hex file to the microcontroller and we will observe the result. Go to File, Import Hex, Counter Delay Switches. Okay, right. Now I'll press switch 1, that is start switch. Counter is incrementing. And now if I'll press the switch 1 continuously, there will be no effect on our program, and our program is incrementing continuously with a delay of 1 second. Now if I'll press the switch 2, counter is stopped, and if I'll press switch 3, counter will be stopped. The duration of the delay, that is 1 second, which we have calculated in this program, will remain same for this program only. If we'll add any other subroutine, it will change according to the length of the program. So to get accurate timing delays, we'll use timing interrupts in our programs, and we'll learn in later programs that how to use timing interrupts. As we have already completed the LCD interface with our embedded system prototype, now we'll test the LCD interface and we'll write 2 programs for LCD display. In first program, we will see that how to write text on LCD display, and in second program, we will learn that how to display the embedded data on LCD display. Here we will use the LCD. It is a 20x4 LCD. It has 20 columns and 4 rows. So first I'll insert the LCD in header socket. And here I'll select the power supply jumper for LCD interface. Here I've selected the power supply jumper to provide the power supply to the LCD display. Now we'll start writing programs on LCD display. As we have the LCD display which has 20 columns and 4 rows, so we can display 4 messages on LCD display at the same time. And now we'll write a program to display the text messages on LCD display. Now we'll start new project, close project, and we'll go for new project, and we'll select standard project. Okay, next. And I'll assign the name to the project, that is LCD project _1, and we'll select the project folder. In MikroC project, we'll select LCD project folder, and here we have the name of the project which we are going to write for our LCD display test, and the microcontroller is PIC16F877A, and the clock frequency is 10 MHz in our case. Okay, next. Finish. Here we have the code window for our project starting from wide main. Now before writing the program, we'll explore another feature of MikroC. We'll go to the project and we'll select edit project. Here we can find edit project window, and here we have the name of CPU, that is PIC16F877A, and the clock frequency is 10 MHz, and here we can find the configuration word, that is 2F4A, and we can see from these configuration settings that the clock oscillator selection is high-speed crystal oscillator. We can have some other options also, that is RC oscillator, low power resonator, but here in our project we have selected high-speed crystal oscillator, and here we can see the watchdog timer is disabled, and here the power up timer is also disabled. Low voltage single supply in system serial programming disabled. EEPROGRAM memory code protection is disabled, that is electrically erasable programmable read-only memory, and flash program memory write disabled. In circuit debugger mode disabled. Flash program memory code protection is also disabled. So if we'll change any setting, we'll have a new configuration word for our project. Say for example, if I select flash program memory code protection enabled, so here we can find the configuration word is changed. And if I'll enable the in-circuit debugger mode, we'll have the new configuration word. So if I'll go for default, we'll have the default configuration word, that is 2F4A. Okay, now we'll write some comments and assignments in our program. Here I've written the comments that my first LCD program dated 1/9/2008, written by Professor Electronics. Now we'll write some assignments to initialize the ports of LCD, and here we will write the port assignments. For this, first we'll refer our schematic diagram, and here we can find we have LCD connections. Pin number 1 is ground, pin number 2 is 5 volt, pin number 3, that is V0. We have connected a variable resistor with this pin to adjust the contrast of LCD. Pin number 4 is RS, which is connected to RB4. Pin number 5 is RW, and will not use this pin. We'll connect this pin to the ground. Pin number 6, that is enable pin, is connected to RB5. Pin number 7, 8, 9, 10, and these pins are D0, D1, D2 and D3. And also these 4 pins are not required to interface the LCD with our microcontroller. And here we have started the interface of data from pin number 11, that is D4, is connected to RB0. Pin number 12, D5, is connected to RB1, then RB2 and RB3. Pin number 15 is connected to 5 volt and pin number 16 is connected to ground, and both these pins are anode and cathode of the LCD. Now we'll go to the help of the MikroC. Okay. And we'll go for MikroC Pro for PIC libraries, and here we will select LCD library, and here we can find the complete description that how to interface the LCD with PIC microcontroller. First we'll go to the reference circuit diagram of LCD interface, and here we can find the reference design for LCD interface with PIC microcontroller. In our circuit diagram, LCD is also connected on port B, and port RB0 is connected to D4, RB1 to D5, D6 and D7. RB4 is connected to the RS pin of LCD, and RB5 is connected to the enable pin of LCD. And here we can find V0 is connected with a variable resistor, which is connected with 5 volt and ground. So we can adjust the contrast of the LCD with the help of this variable resistor. And here we can find that pin number 1 is ground, and pin number 5, that is RW, is also ground, and 4 pins, that is D0, D1, D2 and D3, all these 4 pins are also ground in this circuit. And we have also interfaced the LCD with our microcontroller in same configuration. And here we can find the sample program to display text on LCD. We'll get the help from this sample program, and here we will use the LCD module connections. So first I'll copy these lines from the sample program, Control C, and I'll paste these lines here in our program, Control V, and here we have included the connection information of LCD interface and direction information of LCD interface. But we can find some red lines are there, so we'll go for MikroE libraries, and we'll go for system libraries, and we'll select LCD library, and now we'll compile our program. These errors will be removed. Now we'll write our main program routine, and here we have the main routine starting from void main. So we'll write the while loop in main program, that is while 1 and we'll write our program between these 2 braces. We'll go to the help again, and from here we'll copy some functions and commands for LCD. We'll copy these 3 lines, Control C, and we'll paste these lines before while loop, Control V. Here we have called the LCD initialization routine, and the command to clear the LCD, and the command to clear the cursor of LCD. Okay, now we'll write 4 text assignments to display the text on LCD display. And here we'll write the messages to display on LCD. Again we'll go to the sample program, and here we can find that 4 text messages are written here. So we'll copy these text messages, Control C, and we'll paste these messages here in display messages, Control V, and we'll change the text accordingly. Here I'll write my first LCD program, and this text message contains 20 characters, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So here we have the first message to display on LCD screen. Now we'll change the second text, that is embedded systems, and we will adjust the length of message to 20 characters. We'll add some spaces in the beginning. Now we'll modify text 3, that is prototype design, and we'll also modify text 4 message, and I'll write I can work with LCD. Here we have assigned 4 messages to display on LCD. On first row we'll display the array of characters text 1, and on second row we'll display the array of character text 2, and on third row we'll display the array of characters text 3, and on the fourth line of LCD we'll display the array of character as text 4. Now we'll write these messages on LCD in our while loop. Here we'll use a command to write the message on LCD display, And here we can find that how to write the messages on LCD. So first we'll copy this line from the sample program and we'll paste it here, Ctrl V. The command is LCD out, that is first row and first column, and the text is text1. And here we can find the remarks, that is write text in first row. We'll copy this line and we will paste it 4 times. Ctrl C, and we'll paste it here, Ctrl V, Ctrl V, and Ctrl V. And now we'll modify these commands to display the messages on all 4 lines of the LCD. Here we'll write second row, third row, and fourth row. And in all 4 lines, column will remain 1. Here we have the row and column. Now we'll change the text label, text 1, text 2, text 3, and text 4. And we'll also change the remarks here, that is second row. Now we'll add a delay in while loop, that is delay underscore millisecond 500. So in while loop, each text will be printed on LCD after 500 millisecond. And here we have completed our program, as we have copied the program from the sample program which is given in MikroC help, and we have modified the program according to our messages. Now we'll compile the program and we'll observe the result on our prototype. First we'll save our project, that is LCD project 1. OK, save. First I'll connect PicKit 3 programmer with embedded system. And now I'll run the program for PicKit 3 programmer. I'll go to the file, import hex, LCD projects, and here we have LCD project 1 hex. OK, write. Programming successful. Now we'll power up the prototype and we'll see the messages on LCD display. Here we can see 4 messages on LCD display. That is my first LCD program, embedded systems, prototype design, and I can work with LCD. So in this program we have learned that how to display text messages on LCD display. And in our next program we'll learn that how to display the embedded data on LCD display.